Good morning, dear students. Myself Sushmita, Assistant Professor, EC Department, RCET. So, in this session, we will be seeing about microstrip antenna. So, the outline of this video will be like introduction, and then we will be seeing the types and shapes, also the different types of substrates, and comparison of various types of flat profile printed antennas, as well as advantage and disadvantages of microstrip antenna, applications of microstrip antenna, radiation pattern, and also how optimization the substrate properties is increased bandwidth, comparing the different feed techniques. Now let's see a short introduction about microstrip patch antenna. So in basic form, microstrip patch antenna consists of radiating patch on one side of a dielectric substrate which has a good ground plane on another side. For a good performance, what we have to do is we have to keep a thick dielectric substrate such that it has a low dielectric constant. In such way, it provides better efficiency, larger bandwidth, and better radiation. This particular microstrip antenna, in other words, they can be also called as printed antennas. So they are most widely used at microwave frequency. Why they are most widely used this frequency is, as that particular frequency is that size of the antenna will be directly tied to the wavelength at the resonant frequency. So we can call this microstrip patch antenna or patch antenna as narrow band wide beam antenna. So coming to the feed in the microstrip antenna, we can say that the patch usually feeds along the center line with the symmetry, and it will be minimizing the excitation of undesirable modes. So in other words, we can say that it is easy to fabricate and comfortable at the curve ends. So coming to the directivity, it is fairly insensitive to the substrate thickness. So microstrip patch antennas, there will be the different varieties of shapes like rectangular, square, triangular, or circular. So patcher shapes are single patch radiating shapes, as well as single slot radiator, square, rectangular, dipole, circular, elliptical, triangular, disc sector, circular ring, or ring sector. It will also be having a shape like pentagon also we can go for using, whereas in single slot radiator it will be of different types like narrow slot, circular ring slot, wide slot, and circular patch slot. So next thing is microstrip traveling wave antenna, that is comb MTWA and Meander line, rectangular loop, Franklin type. These are various different types of traveling wave antenna. So we can use different types of antenna according to the desired applications that we are going to apply for. This is another type of antenna, that is microstrip antenna arrays. So antenna arrays, from the name itself we can know that different types of antennas are connected across a single panel to form an array. So that is called as microstrip antenna arrays. So there are different types of substrates like honeycomb, duroid, quartz, alumina. So each and every substrates will be having different dielectric constant as 1.07. Like duroid will be having 2.32, quartz will be having 3.8, and alumina will be having a dielectric constant of 10. So a thicker substrate will increase the radiation power and reduce the conductor loss, as well as it will be improving the power bandwidth. So coming to the comparison of different types of flat profile printed antennas, there are different characteristics as well as microstrip patch antenna and microstrip slot antenna, as well as printed dipole antenna. So we can see the different parameters that has been compared for all these three antenna, like profile, fabrication, polarization, dual frequency operation, shape, and spurious radiation. So next one is advantages. Uh, First and foremost for point of this particular antenna is low fabrication cost. That is, we can manufacture in large quantities, easily integrated with microwave integrated circuits, and it is capable of dual and triple frequency operation, as it will be supporting both linear as well as circular polarization. Whereas the cost will be low, size is small, and low mass. Now, mechanically robust when it is mounted on rigid surfaces, performance will be high, low weight, and low volume. So whereas the disadvantages are like it is narrow bandwidth associated low gain and low ohmic loss, and it will be requiring some excitation on the surface waves, so that we can go for exciting that and produce more radiation at the radiating side. Next thing is, it will be radiating into half space, and it will be having low efficiency spurious phase radiation, that is surface wave stripes, etc. It will be having some amount of spurious feed radiation, that is another disadvantage. And it will be having inherently low impedance bandwidth, a low efficiency, extraneous radiation, and then low power handling capacity. So how we can overcome this particular disadvantage is that low power and low gain can be overcome by array configuration. Instead of using a single piece of arrays, single piece of stripes of microstrip antenna, we can go for using array configuration. And another one thing is surface wave associated limitations such as poor efficiency, increased mutual coupling, and then reduced gain and reduced pattern can be overcome. Whereas some other special techniques that we can go for increasing is that bandwidth can increase up to 60% by using some special techniques. So applications is used in mobile satellite communications, direct broadcast television, wireless LANs, feed element in coaxial system, GPS system, miscellaneous telemetry, and then UHF patch antenna for space. So next thing is, why do we use microstrip branch antenna? So next thing is, why do we go for using microstrip patch antenna? So here are few reasons that is listed out. First thing is flat surface that makes them ideal for mounting on airplane. So as we can imagine that this is a flat surface. When it is a flat surface, we can go for easily mounting on it. Next thing is impedance matching is fairly simple, and then microstrip patch antennas have a very high quality factor. So these are the three different factors that we can go for choosing this particular patch antenna. Coming to the quality factor Q, so it will be representing the losses associated with the antenna, and a large Q leads to narrow bandwidth and low efficiency. So Q can be reduced by increasing the thickness of the electric substrate. When the thickness increases, automatically the fraction of total power delivered by the source goes into the surface wave. So calculating the patch length, PL is equal to lambda naught divided by 2 root of epsilon square, which is equal to 3.00. So one good application of using this patch antenna is UHF, that is ultra high frequency patch antennas can be manufactured by using this antenna. So coming to this Antenna Development Corporation, they have specially designed and manufactured spacecraft microstrip patch antennas for small spacecraft programs. So these particular antennas will be capable of supporting high rates of data transmission up to 10 watts of transmitter power. So mainly they can be used in various applications like GPS, USAF, SGLS, NASA SN, that is including TDRSS forward and return pairs, as well as radar transporter and NASA DSN. So in addition to this antenna can also be supplied with LHCP, RHCP or linear polarization. So next one is the radiation pattern of a rectangular microstrip antenna. So you can see E plane, H plane. The directivity of microstrip as a function of dielectric constant can be computed. So this is how E plane and H plane works. So comparing the different feeding techniques, there are different characteristics as well as microstrip line feed and coaxial feed, aperture coupled feed, proximity coupled feed, spurious feed radiation, reliability, ease of fabrication, impedance matching, and as well as bandwidth. So each of these parameters is taken and the direct feed mechanisms is being compared. So now let's see about the feeding techniques. There are various feeding techniques like coaxial feed, microstrip feed, proximity coupled microstrip feed, aperture coupled microstrip feed, coplanar wave feed, and line feed. So let's see in detail about each and every feed type. First one, microstrip line feed. So in this feed technique, we will be having a conducting strip. You can see in the PPT, that is the yellow color indicated. So that is the microstrip feed. It will be directly connected to the edge of microstrip patch. So this type of feed arrangement has a main advantage that it can be etched at any part of the same substrate that is having a plane structure. So next one is coaxial feed. Coaxial feed is nothing but it will be having a probe feed, which is a very common technique, and it is used for feeding microstrip patch antenna. The main advantage is that this feed can be placed at any desired location. Wherever you want, you can go for choosing the location and you can feed them. So this particular feed method, it is easy to fabricate and it has low spurious radiation. So one disadvantage of this particular coaxial ground plane connector is that it will be having no narrow bandwidth and it is difficult to model. So this is a major drawback of using this particular microstrip antenna. So next thing is the coupling aperture is usually centered at the patch, so it will be leading to low loss cross polarization, which occurs due to the symmetry of configuration. So this amount of coupling from the feed line to the patch, it will be particularly determined by shape, size as well as the location of aperture. So next one is proximity coupled feed. So this particular technique is also called as electromagnetic coupling scheme. So here we will be having two dielectric substrates which are used such that the feed line can be placed between the two substrates. You can see in the diagram we will be having two different substrates and the feed line will be placed between that two substrate. So what is the main advantage? Since we are placing in between the substrate, it will be eliminating spurious feed radiation and also provides high bandwidth since the thickness is overall thickness of this antenna is said to be high. Okay, so next thing is it also provides between two choices, that is we can go for choosing two different dielectric media, one for since we are having two substrate, one for patch 1 and another one for field line, so such that if we are using two, in the sense it will be optimizing the individual performance. So next thing is matching can be achieved by controlling the length of feed line. Okay, so disadvantages, it is difficult to fabricate because the two dielectrics which need a proper alignment. So another one thing is there is an increase in overall thickness of the antenna. So these are the various disadvantages of proximity coupled feed. So I hope you all understood what is a reflector antenna and what are the different types, application as well as advantage and disadvantage, also their feed types. Hope you had an useful session. If you have any doubts or queries, you can do comment in the comment section. Thank you.